And we're live.
So we're looking at uniform motion concepts. Now, uniform means, it's a fancy physics word, it means unchanging. Was Usain Bolt's speed unchanging in the video that you saw? Convince me. Okay. At the beginning, he was accelerating. Once he hit his maximum speed, I think for 300 meters, he could probably keep that up. What if that was a 5,000 meter race? Would his speed be constant after he finished accelerating? No, if you ever watch the 5,000 meters, they do the first lap or two fast, then they settle into a rhythm, and then they'll run the last lap or two fast again. But there, that's not quite uniform. There, if we were finding a speed, we would have to, Hayden, call it an average speed. Okay? Here in the title, uniform motion, we're going to pretend, Leah, that we're traveling at a constant speed. The rate at which an object moves is known as its speed. Let's underline that because that's our key word of the day. And speed is a ratio, that means a division question, of distance over time. As an equation, we say this. Mr. Duick, I get the D for distance, I get the T for time. Why V, Mr. Duick? We use velocity in physics and speed in physics, and we use them interchangeably, but we hesitate if we can avoid it, because what number does that look like? So we're going to say speed, velocity. Don't worry, we're going to get there. Now, you can memorize that equation, but I'm going to suggest to you that almost all of you already have this equation memorized. How many of you have driven on Highway 1 before, the Trans-Canada Highway? What's the speed limit? Out towards the valley. It's a nice round number. And here's my question. 100 what? What are the units? Sorry, what? You told me that we measure speed on the road, and I think most of you know this, in kilometers and per hour. Is that what you said? Doesn't that sort of look like the equation distance over time? It's, if you know how the units of speed are measured, you'll get this equation on your formula. They give it to you on the provincial exam, but I'm going to suggest to you, actually, most of you, without realizing it, know it, because the word per means divide, and it's kilometers per hour. Speed, it's distance over time. Oh, speed has units of, our preferred units are meters per second. That's what we use in physics. However, meters per second isn't that useful for driving. For driving, it's kilometers per hour. And that's in the SI system. SI stands for International Standard. It's actually French. It's System International, but the International Standard. Then we have the Americans who refuse to go metric like complete idiots. So the Americans will use feet per second, or what does MPH stand for? Miles per hour. Americans have a dumb system. How many meters in 1 kilometer? Do you guys know? What? 1,000. Is 1,000 a nice round number? Yeah. Oh, how many centimeters in 1 meter? You guys know? 100. Is 100 a nice round number? Okay. How many inches in 1 foot? 12. Not really a nice round number, but not bad. I mean, you can do lots of math with 12. How many feet in a mile?
5,007.
You're close. It's 5,284. What a stupid number. Who wants to do math in your head with 5,284? The Americans haven't changed. I wish they would, because the metric system is so much better. So much better. End of rant. So I said uniform motion means motion in a steady, unchanging speed. Let's start off with stuff that you know because you've been in the front or back seat of cars. If you're traveling at 80 kilometers per hour, A, how far do you go in 1 hour. What's your distance? 80. How far do you go in 2 hours? What's your distance? This is why I said some of this you'll do intuitively, but for yuckier numbers, we'll figure out how to do it intuitively and then try and generate an equation so that the numbers are yuckier. We can go to our calculators, right? 3 hours. $240. Ooh, half an hour. Uh-huh. That's what part A asks. B says going a little more obscure, but we're trying to build to a mathematical method of getting there so that we can't do it in our head. It still works. Write it as an equivalent fraction. Here's what I mean. The distance that you traveled in 1 hour was 80 kilometers divided by 1 hour. $80 kilometers per hour. Sorry. The speed you traveled. Cross out the V, make it a D. How far did you travel in the second trip in 2 hours? 160. How much time? Does 160 over 2, does that reduce to 80 over 1?
Yeah.
It's an equivalent fraction. What about 3 hours? You traveled 240 in 3 hours. Hey, what does that reduce to in lowest terms? Also, 80 over 1. Oh, what about half an hour? Now that was 40 divided by 0.5. How much you want to bet 40 divided by 0.5 is also 80? And can you see what we're really doing here, Ty, is emphasizing our equation that we're going to formalize. It's a distance divided by a time. Can you see those equivalent fractions? If I know the speed, the distance divided by the time, that's uniform motion. You were doing it in your head, but that's what you were doing. I wrote down here, activity determine the speed of a small battery-powered cart. I couldn't get a hold of the carts yet. We may do this another day, but for now, scribble, 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 scribble. Turn the page. When I teach physics, I'm big on kids having a gut idea of what certain answers are so that when you go to your calculator, you can tell if you've hit the wrong button. So I wrote down here, it's important for physics students to memorize approximate values. Okay, you know what? Be familiar with. Because if I say memorize, there are some of you that are going to spend half an hour memorizing this chart. Don't. But I want to give you an idea of values that are big or small. So we're going to start out with a guess, and then I'm going to tell you what the actual answer is. Take your best guess for how fast, a speed you think for a car on a city street. Write it in your own, on your own. Write down your best guess for walking, and I'm going to give you a hint. Walking, try answering it in meters per second. Take your best guess for what you think a running speed is. Try answering that in meters per second. Take your best guess for a horse at a gallop. Try answering that in meters per second. Best guess for a river flow, meters per second. Trying to get you used to our preferred physics units. How fast do you think sound travels? Now, the one we're going to have to change, light in a vacuum, we're going to have to go to kilometers per second, because if we write it as meters per second, you can't fit it on your calculator. It's too big. Trust me. A jet airliner, you can do that one maybe in kilometers per hour. And then the last one, you all have learned from your science teachers that the Earth is rotating. If you're living on the equator, how fast do you think you're traveling sideways? You can't feel it because the Earth and the air is moving with you, so there's no breeze on your face. But all of us right now aren't standing still. All of us are spinning along with the Earth on the equator. How fast? Best guess. No right or wrong answer here. This is just for you. And then we're going to try and see if we can come up with good answers. All right. You'll be getting your licenses soon. Some of you may already have your license. Car on a city street. How fast?
60.
Okay, city street. Now, first of all, it's going to depend. Rural city street, like inside a subdivision, is... No. Inside subdivisions, they are generally not a school zone. School zone is 30. 60 is in the city when it's a 4-lane road usually. So the Lougheed, for example, is probably 60. Parts of it are 80 as well when you're outside of town. Highways are usually 80. Freeways are usually 100. Although the Coquihalla has some sections that are 110. Okay. How many meters per second is that? If you want to turn kilometers per hour into meters per second, you might want to write this down in the margin. This is going to be your handy dandy note. Divide by 3.6, and I'll tell you why later once we're more comfortable with the equations. 50 kilometers per hour, if you divide that by 3.6, how many meters per second? Miller. I missed the first digit, sorry? 13.9. Is it 13.88888888 or something like that? Yeah, so 13.9. You've been in a car on a city road. Ask yourself, or next time you're driving, see if you notice, in your mind, pace off about 1 second. Keep track of how far you go. See if it's about 14 meters. Should be. Walking, easy pace. How fast do you walk at? We can find out. Distance was 6 meters in how many seconds? Look, if it's meters per second, shouldn't I put the number with the meters on top? 6? And shouldn't I divide by the number of the second? It's going to be 6 divided by 5, whatever the heck that is. You know what? Around 1.2 meters per second. I don't memorize the decimal. We walk at roughly 1 or 2 meters per second. 3 meters per second, you're walking pretty quick, speed walking, in a hurry, trying to catch someone. 1 meter per second, you're strolling pretty casually. So if they're asking you a question about finding the speed of somebody walking and you get an answer of 119 meters per second, you know you're wrong. Okay? Running, fastest man. How fast in meters per second? Okay. Who is currently the fastest human in history? How far does he run? The one I showed you, but what's his standard one? What's he most known for? Okay. Let's try the same trick. 100 meters divided by... How fast does he run it in? You say 8 seconds? Are you... No. He's not 9 either. He's not below 9. He's about 9.7. I think the best he's done is 9.59. How about 9.6? Okay. Distance over time, again. How fast? Can someone crunch the numbers? What is 100 divided by 9.6? 10.4-ish. We'll go to 1 decimal point. About 10.4 meters per second. How many kilometers per hour is that? Okay, you ready? Going to put our thinking caps on. If to go from kilometers per hour to meters per second, I divide by 3.6, what would I do to go in the other direction? What is that? 37.4? Put your pencils down. Oh, first of all, let's write that answer down. 37.4 kilometers per hour. I wonder. Horse at a gallop. 5 meters per second? Maybe. This one, unfortunately, I know in hang on. I know this in... Was there a delay? Okay. So first of all, as science nerds, we can answer this question. What travels faster, light or sound? The light clearly got to your eyes way faster than the sound. How far away is that bridge? You know, if we knew how fast sound traveled, and we timed how long it took from the explosion to get to our ears, figure out how far away the bridge is. Later. Later. Sorry for those of you who are watching at home, I forgot to hit continue. Anyhow, turn the page.
That was interesting.
It was nerdily cool. So for an object that's moving uniformly at a constant speed, like the car in example 1, the speed ratio will always be the same, 80 kilometers in 1 hour, 160 kilometers in 2 hours, 240 kilometers in 3 hours, 40 kilometers in a half an hour. It gives us our word equation. Speed is the distance divided by the time. Or if we want to write it as an equation, V equals D over T. By the way, when I write the letter T in physics, I'll always make it curly, because I'm a math nerd teacher. I'm worried if I write that, I'll think it's a plus sign. You don't have to, but it's a habit I developed long ago. That's a T. So, imagine you're traveling at 120 kilometers per hour in your car on the highway. A says, interpret the ratio. In 1 hour, how far will you travel? How about in 2 hours? How about in 3 hours? How about in half an hour, 30 minutes? All right, how about in 20 minutes? What fraction of an hour is 20 minutes? It's 1/3 of an hour. What's 1/3 of 120? Divided by 3. 40. 40. Oh, what about in 15 minutes? What fraction of an hour is 15 minutes? 1/4. 120 divided by 4, 30. That's what that ratio means. Oh, B. How fast are we going in meters per second? What did I say on the previous page? To go from kilometers per per hour. It's something to do with 3.6. Divide or times? Which one? Divide? And in a day or two, I'll tell you an easy way to remember whether you divide or multiply, but you are going to have to remember the 3.6 part. What is that? I think it works out evenly. Sorry, Dane, what? 33.3 meters per second. Next one. It says, estimate the speed of a BC ferry traveling from Tawassen to Schwartz Bay. The trip takes approximately 90 minutes. Distance is about 55 kilometers. What do they want us to find here? Speed. You know what? I'm going to go speed equals distance over time. I need the distance. Did they tell me the distance? How do you know that's the distance, by the way? Say it louder. One of the things I'm going to try and teach you, and especially if you take Physics 11 or 12, I'm going to say memorize units. It cuts down on your thinking, because if you're looking for a distance, what you're really looking for is either meters or kilometers. Or if you're in the frickin' US, feet or mile. Here, meters or kilometers. 55 kilometers. Let's write that down. I guess I need time. Did they tell me a time? I got a problem with 90 minutes. What's my problem with 90 minutes? I want either hours or if I want to go meters per second. But since my distance is in kilometers, I think I want kilometers per hour. All right. Here's another note. How do we change minutes to hours? It is an hour and a half. You were able to do that one intuitively because most of you have dealt with 90 minutes. What if it had been 117 minutes? Let's see. If it was 60 minutes, how many hours is 60 minutes? 1. 120 minutes. How many? Okay, mathematically, what do you do to turn a 60 into a 1, to turn a 120 into a 2? Now, some of you already said this because you know it, but if you forget, I'm trying to show you a way you can use easy numbers to just figure it out on the fly. What do you do to go from minutes to hours? Divide by? Divide by? 60. 60 divided by 60 is? 120 divided by 60 is? 90 divided by 60 is, and Sarah knew this already, but we can prove it. You know what 90 divided by 60 is? Darn right, it's 1.5. And now we're good. Speed equals 55 divided by 1.5. The average speed, because I think ferries speed up and slow down, so really what we're finding is the average speed. But the average speed is what? Having fun, Miller? Don't stay like that. 55 divided by 1.5, 36.6 or 7. If I round off properly, 36.7 kilometers per hour. Those ferries actually almost do road speed. They do school zone speed. They're pretty fast on the water for something that big. So here's our summary. Okay. Our word equation is distance over time equals speed. You can remember that, Sarah, just by looking at the units. How fast are you going? Kilometers per hour. I'm pretty sure that's distance over time. It is on your formula sheet, but if you haven't to look it up all the time, you're just going to get sick and tired of looking it up, so I'm trying to give you a way you can remember it. As a formula, V equals D over T. Just wondering. This equation here, this one, it's actually 3 equations in one. What if instead of saying, here's the distance, Here's the time, how fast. What if I told you how fast and the time, and I said, what's the distance? So Darian is saying there's like a triangle thing. I loathe that triangle thing, because that triangle thing only works for certain types of equations. If I have to, if you're really uncomfortable, I will teach it to you quietly. What I want to instead teach you how to do is how to deal with any equation on the planet. So you ready? How would I get the d by itself? What else is on the same side as the d? A t? What's the t doing to the d? So what's the opposite of dividing by t? How would I move it over? Another equation is this one. No triangle needed. Another equation is this one. That one's a little tougher to get. We'll talk about how to get that one another day. But it's really 3 equations in one. I know this one intuitively because it's kilometers per hour, it's distance over time. And I can usually figure out the rest. What's your home? Is that it, I think, Mr. Duick? Yep. What's your homework?